Let's get started. Thanks for coming to my session. Hi, I'm Trustin, and it's very nice to present my talk in sunny Barcelona. I'm going to introduce the project called Armeria today, especially from the viewpoint of Spring Framework users, as well as legacy migration. Before getting started, let me give you the overall structure of this talk, so it's easier to follow. We'll start with some basics about Armeria, like what Armeria is, how it compares with others, who's behind it, and who are actually using it. And then we'll do a quick tour of the typical migration process we usually experience in real life. And then we're going to learn how we can simplify everything dramatically with Armeria. And I will also introduce a few interesting features of Armeria you will get for free by using Armeria. After that, we're gonna go into some code level detail to show you how to use Armeria in your Spring Boot application. After that, I'll finish the talk with the roadmap, recap, and Q&A. Okay? So, how many of you have heard of Armeria? Please raise your hand. Oh, that's more than I expected. Great, thank you. It's obviously not a very well-known project. Personally, there was always a fun moment where people mispronounce it as Armenia, the country, or Armeria, the city in Spain here. But that's fine, because I believe you won't make the same mistake again from this moment. Cool. So please feel free to scan the QR code or go to armeria.dev from your phone while listening to my talk to get more information of it. Let me wait a few seconds. Okay. All right. So because you're already quite familiar with Reactor and Tomcat, it's probably better starting with a comparison like this to give you some quick impression of Armeria. The project Reactor Netty HTTP, more specifically, implemented its own HTTP stack on top of the Reactor Core API, and it uses Netty as a networking layer. Netty is a de facto standard for high-performance networking in Java, as you know. And the Apache Tomcat, on the other hand, implements the Jakarta E servlet specification using the standard Java API for networking. And you can also use a native library called TC Native to accelerate certain functionalities like, TLS and cryptography. Armeria is very similar to Reactor. It uses Netty as its networking layer. It uses its own reactive streams implementation, which is compatible with the Reactor and RxJava. As for the supported HTTP protocol versions, as of today, they all support both HTTP 1 and 2, and both clear text and TLS. But about a few years ago, some didn't support a certain case, like a clear text HTTP2, but they eventually caught up with each other. But if you're using an older version of Tomcat or Spring Boot for some reason, then you'll see the difference. So if you're stuck in an old version of a Spring Boot or Tomcat, you might want to consider Armeria as an alternative HTTP engine because it supports all the versions of Spring Boot and Tomcat, like Spring Boot 2 and Tomcat 8. And it allows you to handle, HTTP 2 completely transparently. Like, for example, Tomcat 8 has no support for HTTP 2, but if you use Armeria as an engine, then it suddenly becomes capable of speaking HTTP 2. And same story with Unix domain sockets. Unix domain sockets are supported by all three as of today. But if you're stuck with an old version, Armeria can be useful. And besides that, Armeria has good support for proxy protocols like HA proxy and SOX. HProxy HA proxy is the protocol used by HA proxy as well as Amazon Web Service Elastic Load Balancer. So you don't need to rely on HTTP headers like forwarded for if you use these kind of protocols. And it also has support for high-level protocols like gRPC, Drift, GraphQL, WebSocket, etc., which is something you might be interested in if you are looking for a lightweight way to build a service. On the client side, Reactor provides the core HTTP functionalities to Spring APIs, like a Spring HTTP interface, web client. Armeria is also capable of doing the same, but plus it integrates with other popular client libraries like Retrofit and REST-easy. So to summarize, Armeria is a reactive HTTP engine with good integration with third-party technologies, Spring and non-Spring alike. Reactor Netty HTTP is a library that provides core HTTP functionality to Spring Reactive Stack, leaving the high-level functionality to Spring Framework. And Armeria has slightly better protocol support, like proxy protocol or high-level gRPC support, stuff like that. And on top of that, it has a few interesting features. For example, it supports port unification, which is like serving HTTP, HTTPS, and proxy protocols in one single TCP/IP port by auto-detecting protocols. It can be useful when you have some restrictions on network policy and stuff like that. And it also has very detailed request logging API that allows you to access every single aspect of your request using API or using your data pipeline like Kafka. On the client side, it has a very powerful service discovery mechanism and load balancing mechanism like XDS built-in, all built-in. But I'm not going to talk too much detail about this in this talk because it's more about Spring and Armeria. So Armeria is an HTTP engine, but it is also a web application framework by its own. So for example, you can write a service like this without integrating with the Spring Web. If you want to go very, very lightweight and Spring-free, this is also an option. However, what makes Armeria shine is its ability to integrate many different technologies. Here, we built our server to serve 3 different application level protocols: gRPC, GraphQL, RESTful API. It also provides some useful implementations like Prometheus exposition service and health check service to expose the metric and respond to the health check request from a load balancer. And there are also decorators that intercepts the request and responses to provide some common functionalities for building a service. Like for example, authentication, distributed tracing, metric collection, and logging. Okay, so we now know what Armeria is, but we don't really know much about the people behind the project. So we obviously don't want to rely on a project without a good community, right? So Armeria is an open source project started about 9 years ago by me. It started as an attempt to replace the Tomcat-based legacy Drift server, but it is now much more than that, as you see. We have more than 4,000 GitHub stars and more than 200 contributors, which I really appreciate. And there are currently 4 full-time engineers who maintain Armeria, answering your questions and fixing reported bugs every day. And over the last 9 years, we gained a fair number of internal and external customers. They use Armeria in production. Slack was our first external customer, and they successfully migrated their Drift-based search backend into gRPC. Databricks is also migrating their Jetty-based RPC stack into gRPC using Armeria. I'll not mention every single use case here, but the point is that we have many external customers in diverse industry, and we work together to build a healthy community. Okay, now we know what Armeria is and who's behind it. Let's revisit what we do every day. What do we do every day? It's migration from one to the other. It can be one protocol to another, like a REST to Drift and to gRPC, or it can be one version to another version, like API version 1 to 2, 2 and 3. And in this talk, as an example, let's say we migrate a legacy Tomcat service into WebFlux. So in the beginning, things are really simple. You have a Tomcat server that runs your web application. But things change as time goes, and realize we need to replace it with something. It could be a new protocol like gRPC, it could be a new implementation of the same REST API, or it could be a new redesigned REST API. So it could be, so the truth is, it always happens for many different reasons, and we end up doing migration. The typical solution for preparing the migration process is to add a reverse proxy in front of the legacy server. It can be Nginx, Envoy, Traffic, HA proxy, Elastic Load Balancer, etc. But it has to be there so we can begin. Then we add a new server and redirect some or all of the incoming traffic to the new server. It can handle a portion of the API, like /API/users, or a certain new version API only, like /API/version 2, or maybe gRPC traffic only. So as you feel more and more confident, you redirect more and more traffic. So if everything goes well, the migration will be complete at some point, right? But if your API surface is not small, the whole migration process can take a lot more than just a few weeks. It can take years until all your customers migrate away from your old endpoint. Or maybe they may differ as much as they can, or even refuse to migrate, right? And then it's not migration anymore, it's coexistence. And believe me, this happens a lot in real life. Anyway, let's say we somehow finished the migration successfully and all traffic is redirected to the new service. We now need to think about the reverse proxy we added in the beginning. So should we keep it or not? It takes energy and coordination again to remove it, so it is sometimes just left there, just doing nothing useful, or some people even try to introduce more features to it. And the question is it worth? Is it worth maintaining it, like updating in response to security issues, or or monitoring it continuously? Is it worth that continuous effort? I think we need to go back to the beginning and better understand why we needed a reverse proxy. Of course, there are some legit use cases like canaries, blue-green deployments, and like that. But it doesn't make much sense to run multiple servers only because they have different protocols or different API design. It's an arbitrary limitation forced by the application framework. Actually, if you look into the current landscape of the industry, you'll realize that multi-protocol is the new normal. People use REST API to external customers, while using gRPC for efficient internal communication. Some even expose both REST and GraphQL together, like GitHub does. And for example, a gRPC server should be able to speak more than gRPC. It needs to respond to health check requests from load balancers, and it also needs to provide metrics to Prometheus scrapers. It sometimes needs to serve static resources. So it's always a multi-protocol, even if you try to introduce just a single protocol. So far, we had to serve a separate server for each different protocol, even if what they do is not very different from each other in terms of business logic. So they basically do something similar in terms of business logic, but their protocol is just different, and they have different servers. This is not natural, in my opinion, and this makes things unnecessarily complex. So now imagine, what if we have everything in one service, one port, and one JVM? Our operation complexity will go down because we don't have to operate multiple server instances as well as reverse proxy just because of this. And our code and build complexity will also go down because we don't have to modularize our service excessively. And this is where Armeria tries to solve. Okay, so we revisited the typical migration process and why it's painful and why reverse proxy is not the best solution. And now let's see how we can simplify migration with Armeria. So with Armeria, reverse proxy is not needed at all for the scenarios I mentioned above. So you can just add a service for each different protocol or endpoint, and Armeria will serve them all in a single HTTP port and a single JVM. This means you can serve a REST API, gRPC, Drift, GraphQL, servlets, and WebFlux, all coexisting in a single server instance. There's no drama, it just simplifies everything. So to give you a more concrete understanding of what's going on, I'm going to show two migration scenarios. One is to migrate an existing REST API based on Spring Web to gRPC, and the other is to migrate a legacy servlet to Spring Web. So let's start with the Spring Web to gRPC scenario. Typically, your app is a Spring Boot app, and you use Reactor or Tomcat, depending on whether you're using reactive stack or not. Now, let's say you decided to go with gRPC for internal communication for more efficiency and type safety. Because Armeria can replace Reactor and Tomcat, you keep your Spring Web service and then add a new gRPC service alongside. Armeria will handle and route all the traffic accordingly. Now, let's compare this with other options like gRPC Spring Boot Starter. It's a simple facade to Google's official gRPC Java implementation, and it has its own HTTP stack, which means, first, you have to set up a reverse proxy anyway because your server will open two ports. And you have two different HTTP stacks to understand when troubleshooting because Reactor, Netty, and gRPC Java both use Netty, but their implementation is actually different. And Armeria has a very feature-rich gRPC implementation, so it supports various gRPC variants. For example, gRPC Web allows a web browser to make a gRPC call, and HTTP JSON transcoding allows you to transcode a gRPC into RESTful API, just like Google does for their cloud API. It even allows clients to call gRPC over HTTP1, which is originally impossible with the official gRPC implementations. Without Armeria, you need a dedicated reverse proxy or API gateway for these features. Again, this is an arbitrary limitation enforced by your software stack, not the design actually. And I did not explain the last bullet, no doc service, because it needs its own slides. Okay, so doc service is a web-based UI that allows you to browse the API specification of your services. It works for gRPC, Drift, GraphQL, and some REST APIs. It works well, especially well for RPC endpoints like gRPC. So as you see, you can browse the list of RPC methods easily. And you can also browse details of the request and response types, like you browse Java doc, which is very useful. And it also allows you to send a request in human-friendly JSON format to your gRPC endpoint, which is much easier than, the traditional way of making a binary RPC call. So with this form, you don't need to write any code to make a gRPC call. There's no need to provide a .proto schema file because doc service already knows the complete schema. It has auto-completion, schema validation, and on top of that, you can share the request with your colleagues as a URL or curl comment so that, your colleague can reproduce the problem using the problematic request very easily just by sharing the URL or curl command. Okay, and the second scenario is servlets to Spring Web. So if you have some legacy servlets and you want to migrate to Spring MVC or WebFlux, you can simply add a Tomcat service or a Jetty service to Armeria server to run the legacy servlets alongside your Spring Web application. So you can even, for example, you can even run multiple Tomcat services or mix Tomcat service and Jetty service together. So problem is easily solved. So let's say you have one Jetty-based legacy servlets and another servlet application based on Tomcat, and you usually need to run in two different instances, but not anymore. So we now know how simple it is to perform migration from one service type to the other when using Armeria. But do you feel like trying it by yourself? Nope, yet? I don't know, but we'll see. I hope so, at least. So now let's see how to apply Armeria to your existing Spring Boot application at the code level, either reactive stack or not. So let's start with the reactive stack because it's a little bit easier. We first add Armeria Spring Boot 3 starter as a dependency. You can also add the actuator support by adding Armeria Spring Boot 3 actuator starter. So as you can guess from the artifact ID, we also support Spring Boot 2 just in case you're stuck with it for whatever reasons. Once we add the dependencies, we update our application.yaml to tell Spring Boot to use Armeria as its HTTP engine. So we first disable the embedded web server and then add a section called Armeria to configure the ports. Then we specify the list of the internal services they can run in a separate port for administration. Finally, we can override some optional properties. No, you're taking picture. I can wait. Cool. All right. And then the final step is to provide an Armeria server configurator to configure Armeria or bind more service to it. So the next part of the talk is going to be about migrating, integrating with the Spring Boot, Spring MVC. So in this case, we're gonna reuse the embedded Tomcat server created by Spring Boot and plug it into Armeria server, so that Armeria handles all the HTTP requests. And then once Armeria received a request, the request will be redirected to the embedded Tomcat created by Spring Boot. Thank you. All right. Where's my cursor? Okay. So yeah, the whole integration process takes under 30 minutes. So please feel free to give it a try later today. And if it does not work as expected, feel free to visit our GitHub or Discord server and just tell us. We'd be very happy to look into it. And switching from Tomcat to Armeria is slightly more complex than switching from reactive stack, but it's still fairly straightforward. You first add some dependencies. This time you add Armeria Tomcat 10, so we can use Armeria's Tomcat integration. And besides that, there's no difference. In the application.yaml, unlike the reactive stack, we want to reuse the embedded Tomcat created by Spring Boot. So we just don't want it to open a TCP port, because Armeria will handle all traffic. So we specify a special port number, -1. Then the rest is the same with what we did for reactive stack. The configurator bean part is more complex because we are reusing the embedded Tomcat managed by Spring Boot. So we let Spring to inject the serverless web server application context, which gives the access to the embedded Tomcat instance. From the context, we retrieve the Tomcat connector, which is a gateway of all Tomcat requests, and we wrap it with Armeria Tomcat service. Finally, we add the Tomcat service to Armeria, so the requests are routed to the embedded Tomcat managed by Spring Boot. It looks somewhat complex comparing to switching from reactive stack because it's how it is, but it's just a one-time thing. So as you saw so far, in a single server instance, you can mix and match different types of services, greatly simplifying the migration process and letting heterogeneous services coexist with each other. However, it's not a silver bullet, of course, so there are some limitations. For example, Spring interceptors like Spring Security cannot affect non-Spring services, obviously, like gRPC. Because of this, some Armeria users rely on Armeria decorators to implement or reuse what's provided by Armeria to provide the similar functionalities like authentication, tracing. These kind of functionalities are also provided by Armeria as a decorator. So instead of using Spring Interceptor, if you use Armeria decorator, the common functionality is applied to both Spring services and non-Spring services like gRPC drift. Alright, so thank you for focusing on the talk and staying with me. Now I'd like to mention what we are up to in Armeria and recap this talk. So Armeria team's main focus these days is to add full XDS support which can remove the needs for sidecars completely in our microservices, of course. And we are also working on better virtual thread support. And we want to improve doc service to provide more, advanced features like complete dashboard. And we also want to support more protocols at various levels, like low-level HTTP3, high-level socket IO. And in the long term, we also want to improve the developer experience of the project even further. For example, by introducing automatic reconfiguration, live reload, and besides that, we want to integrate with even more technologies and specifications like Open API. And we already actually have Kotlin and Scala integration, and people are happy with it, but we want to improve it even further. And if you are interested in any of these features, please visit our community and let us know what you think. And we're actually very open to your, feedback for you to steer our future direction. So your feedback is always appreciated and important to us. So to recap, Armeria is a reactive microservice framework built from ground up for powerful integration, providing wide range of microservice features. And it integrates with Spring Boot nicely, providing many benefits, including unified multi-protocol support, gRPC, gRPC web, HTTP JSON transcoding, and online API ground provided by doc service, and the ability to host different types of services from reactive web apps to gRPC and GraphQL to even, legacy servlets. So why don't you simplify your application architecture with Armeria? You don't always need a reverse proxy to solve your problem. It's just a limitation we currently have. So thanks for attending this talk, and if you like this talk, please visit our official website, armeria.dev, or add a GitHub star to our repository if you like it. And we also have a Twitter account to follow and Discord server to check. So please feel free to join our community. Thanks. Yep, questions?
I guess this is a question regarding Armeria, but maybe also Netty, and this is a good thing you are here because because you can't escape the question. So,
okay.
Armeria was conceived as a reactive server, I guess, in a time that virtual threads or project loop were only inceptions or maybe didn't exist at all, right? So what's the future of reactive infrastructure underneath Armeria or even Netty in the world of production-ready virtual threads in Java? It's the event loop thing that it made a lot of sense because we don't have something like that, something like the Node.js event loop. We don't have that in the JVM. But nowadays and in the future, you think the trend for Armeria and for Netty is to embrace virtual threads and maybe left the event loop paradigm, or you think it's valuable, this mechanism, even when you could use virtual threads?
That's a good question. So the question is, now that we have virtual threads and advanced constructs for easier threading model while having good performance and throughput. So what will happen to netty or event loop-based mechanisms and reactive streams? That was the question. So I think netty will continue to live on as its own solution for low-level networking infrastructure for building high-level servers. So I think, and it also has some kind of freedom to introduce more native stuff. Like for example, it introduced Unix domain sockets even when JDK didn't have support for it. Or it recently also had IO U-ring support, which is also not available in JDK. So there are always some places to fill for netty, between cutting edge technologies for high performance networking and JDK. So JDK will eventually catch some up, and netty will do something more useful, what it can like what it can do. And for Armeria, its core is based on reactive streams, but now that Project Loom virtual threads are gaining a lot of traction, we need to think about whether this is the best way to write high-level application. For some people, reactive streams API is not really easy to grasp. So the option we are currently thinking of is to going multi-paradigm. So some users who are actually comfortable with the reactive streams API, then they could continue using the current API. But if people, some people don't really get it, or some people just don't want to use it because there's much simpler way now. So in that case, we could provide an alternative API that allows people to write just like writing blocking code. So that's something our Armeria team is looking into. So for now, our main API is reactive streams, but we want to provide both options to our users so that they can choose whatever they want. Any other questions? So we have a Discord server, and we also have a GitHub repository, so just feel free to contact us. We'd be very happy to answer your questions. Cool, thanks.